Before we go over 5.2 today, I want to review a little bit about what we did last time, and because today's topic is dividing monomials, and before we get there, because this is in your homework for tonight also, so I wanted to go over this, review a little bit about GCF. Remember we learned what GCF was last time? So. Who remembers what GCF was, first of all? What does it stand for? Okay, that everyone knows. Yeah, what that? Greatest common factor. Okay, so you guys remember we talked about in length, what it is really, right? So what's our step one? Every time you're finding GCF, to make sure that we have the right GCF, our step one is, yeah. You factor the two numbers using, it's called prime factorization, right? Another name for that is what? Alvin? What's another name for prime factorization? Pay attention. Yes, factor tree. So, and because I'm so nice, guess what I did for you guys? I did it for you. Am I not so nice? This is great. Great. Okay, so I did one for you. So that we did the step one for it. Now, who remembers the most important step? After you do a factor tree, what did I ask you to do? With the to find the GCF after you do a factor tree. Yes, sir. Find the common factors and choose the smaller. I think I wrote it wrong yesterday. It should be choose the smallest exponent, not power. I think I wrote powers. Powers is the whole thing. Yesterday when I wrote down the instruction, I said choose the smallest power, but it should be choose smallest exponents of the common factors. Okay, does that make sense? Sorry. Okay, so anyway. So what is the common factors, first of all? Ratio n. How many common factors do we have in this two numbers? One person though? That's it? Ben? Jimin? 2, 3, and 5. What about 7? Is that a common factor? No, that's why we do the factor tree, right? Because you can see the common factors really easily. Does that make sense? Because if I give you like some big number, is it easy to see the common factors? Unless you do a what? Factor tree. Does that make sense? So you're right. 2, 3, and 5. Now, which exponent should we choose? Question?
Yeah. For the GCF, is it like the biggest factor that's prime, or just the biggest factor?
It's the biggest factor that could go into both of these.
Oh.
Yeah, it's the biggest. That's why it's called greatest common factor.
Okay.
Yeah.
So it didn't have
Doesn't have to be a prime number. No, it's not prime greatest common factor. It's just greatest common factor. Okay, so that's a good question. So, but we do need to do a factor tree using the primes, right, Sarah? In order to see what the common factors are. I think that's where you're getting at. So what are the common factors, first of all? Is 2 a common factor?
Yes.
3? 5? 7? No. Okay, so 2 to the which power should we choose? We say choose a smaller exponent because we got to make sure it goes into both of them, right? 2 to the what power? Second. 3 to the first. 5 to the? Second. That's right. There's your answer. Easy. Now, if you were to multiply this out, does anybody know what you get? Because this is something, yeah, Ethan? 300, yes, that's right. So you get 300. See, I wrote this step 2 down here. I wrote down, instead of exponent, I wrote power yesterday, I think. So, sorry. But choose the smaller exponent, not power. I wrote power by mistake. Choose the smaller exponent of the common factors. Yeah, question? Oh, you're confused as to why I got 2 to the second? Because look, is 2 a common factor? Of these two numbers, the one on the left and the one on the right, is 2 a common factor? Yeah. So which one do we choose? 2 to the third or 2 to the second? 2 to the second is smaller because if I were to choose 2 to the third, right, then that number would not go into this number on the right ever. It's too big. You know what I mean? That's why we choose the smaller exponent. To make sure that that number, the greatest common factor, that will go into both of the numbers. You guys remember that? All right, now today on your homework, it's going to be very similar to this, but guess what? They're going to have, instead of just numbers, that will give you some exponent. We're going to have exponent. They're going to give you some, not only just numbers, but they're going to include some variables. That's correct. So this is what you have for tonight. Instead of just numbers, now again, I was really, really nice. Why? Because I did the step 1, what? For you. Didn't I? You didn't have to do a factor tree for these. Now what do you think you're going to do when you have some variables along with all these numbers? Sarah?
Will the GCF be along with the biggest exponent?
Biggest exponent? Do you think it's going to be different than what we did last time? Now that we introduced the variables? No, it's the same. To find GCF, it's the same exact steps. So first you do a factor tree, right? By the way, do you need to do factor tree for these variables? No, why not? Why don't we need to? How come we don't need to do a factor tree for these variables? Well, the numbers I did it for you, right? But do we need to do a factor tree for these variables? No, why not? Can somebody say? It's kind of obvious. Why don't we do a factor tree for the variable? Yeah. No. Now, what I'm saying is x squared, y cubed, z fourth, x, y squared, z fifth, t to the sixth. Do I need to do a factor tree for those? Victor? What? You can't factor them? That's not why, no. Yeah. It's already in exponential form. You don't need to do any work. You know what I mean? Look. Aren't they already in exponential form? They're already factored, if you want to think about it that way, right? They're in exponential form. You don't need to do any factor tree. You know what I'm talking about? So I did step one, right? I'm done with step one. You know what I'm talking about? At least for the variable part, yes. Do you think all your homework, these numbers will be already factored for you? No. But these variable parts, they're always going to be exponential form like that. So you don't have to worry about the variable part. So when you do a factor tree, guess what? You just do it for the numbers, not the variables. You don't need to do it for the variables. They're already factored. So who can tell me what are my common factors are? What are my common factors? 1, 2, 3, 4. That's it? 4 people see it? It's the only thing difference is just now you have some. Eddie, can you tell me some common factors?
2, 3, 5, x, y, z.
That's right. 2, 3, 5, x, y, z. What about t? Is that a common factor? No, it's not in the first monomial, is it? What about 7? Is that a common factor? No, it's only in here, not on the other one. So it's 2, 3, 5, x, y, z. Now, 2 to the which power should we choose? Again, 2 to the? 3 to the? 5 to the? Oops. Uh-oh. And then x to the what power? First. This one has no, nothing in there. It's really x to the first, right? What about y to the? Z to the? Fourth. What about t? No. So did you all get this? And isn't the same? Look at the coefficient. Wasn't it the same thing? How many people realize it was the same exact numbers? See the first example? It's the same exact coefficient number. But anyway, okay. So any question as to how to do these? How to find GCF when you have variables in them? Does that make sense? So now we're ready to divide monomials. Are you okay with that? So I did that first so that you get, you're going to have something like that for your homework. So this fact one, I think a lot of you already know. Now, if I have a times c over b times d, is there a way to write this as a product of fractions? Eddie,
A
2.
goes over b over d times c over b over d.
No, it would not be a over b over d times c over b over d, because then you would get on the denominator, because you have to multiply across, you would get b squared d squared on the bottom. You will get a c on the top. Does that make sense? Anybody want to try? Yeah.
A divided by b times c divided by z.
In other words, can you write that as a fraction? What would that be? What would that be as a fraction? What's a divided by b mean? In other words, how do they get this? Can we just multiply two fractions and get a c over b d? Yeah. You right. So is there a way to rewrite this as a product of two fractions? Yeah. Yeah. Maybe it was so obvious. Maybe you all knew, right? You all know this, right? We don't normally go this way, do we? Don't we usually go from this side to the left? But is it okay to write the other way? Is it possible? Yeah, because how do you multiply fractions? You multiply them across, right? With the numerators together and the denominators together. Isn't a over d times c over d same as ac over bd? So it's a fact that you already knew this, didn't you? Okay, so now, but any question? Do you understand? I think maybe it was so easy, you guys. Okay, but every time I do this, I have to do something like this. Why? Where does that come from? Why do I have to write B can't be 0, D can't be 0? Why is that necessary? Clear?
Because you have to state the restriction.
You have to state the restriction. Because what happens if B or D is equal to 0? Stefan?
You're dividing by 0.
You're dividing by 0, which means it's undefined. So we want to make sure that B and D does not equal to 0. Is that okay? So that's why you will see that whenever you have, especially when you have, right, variables on the where? Denominator. Do we worry about the variables in the numerator? No, they could be 0. We don't mind. But variables in the denominator can be. Okay. Question?
Oh, yeah, so why can't they be like undefined? Like it doesn't say like being one.
Right, so when we talk about these expressions, we want them to be defined, not it's undefined. So yeah, that's the reason why. Yeah. So can you then do an example? Whoops! If I show you the answer. So let's do a very simple one now. Can you try example 1? Here, if I ask you to simplify this simple fraction, 15 over 21, I know that a lot of you could do this in your head. What does that become, by the way? 5 over 7. How did you get that? Divide top and bottom by 3 over 3. So, knowing that rule that we just learned, is there a way to do that by separating this into two fractions? Yeah, Sarah.
5.
No, you're right. 5 times, what's 15? 5 times
3.
over, what's 21?
7 times 3.
Yeah, 7 times 3, so isn't that what you get? Right? And so what's this really? 3 over 3 times what? 5 over 7. So, we're just using that. I mean, normally you don't do it this way, but I'm just showing you that you could use this rule. It works. What's 3 over 3, guys? 1, so you get 5, 7. Any question? So another way of representing dividing top and bottom by 3 is, separating this into two fractions. Question?
We have to do this on our own.
No, but for something like the simple ones, no. But this is going to be helpful. That's why I'm showing you. Okay, so I'm going to start with something very easy, and you will know why this is useful. By the way, okay, any question? Let's get it. Does that make sense? So we just learned that A times C over B times D is equal to, again, what? A over B times C over D. What happens if A is equal to B? Does anybody see what would happen if A is equal to B?
Oh my gosh, I know.
Yes.
Sorry.
It would just be C over
It will just C over D. Why?
because A over B would equal 1.
Yeah, it would be 1 because. So that's something that you should know. So if A is equal to B, then you get B over B, right? So B over B, what's B over B? 1, right? So in other words, if I have B over C, BC over B over D, you just get C over D, don't you? Because B is cancelled out. It's kind of obvious. It's something you already knew. I'm just kind of saying this. But do you see a little star? Why do we need B can't be 0 there? Because didn't the B's cancel out already? Right? Why do we have to bother, right? Why do we have to say, well, I understand why we have to write D can be 0, right? Because it becomes C over D, right? So we don't want D to be 0 because then it will be undefined. But didn't the B's cancel out? Why do we have to still say B can't be 0 even though we cancel them out? 2 people see it? 3, 4? Do you know my question? Do you know what I'm trying to ask? Look, B is canceled out. Why do we even have to bother writing B can't be 0? I mean, didn't the B's cancel out? Don't we just have to worry about D? Why do we still have to say B can't be 0? Paul?
0 times
0 times